get set for the next run.
So the riders have their challenges here. It's a very technical course, very big jumps.
The cannon, the step up.
This is Red Bull Hardline, the toughest downhill race on the planet. Oh, big throw! Oh, low goes down!
Hello! Today we will review live streams with a Raspberry Pi 5 and a camera module version 3. The first question is, why is it so important to have a zero latency video stream? Of course, it depends on the task. The latency doesn't matter if it's about recording birds outside your window, or if it's about a Taylor Swift live concert. However, the latency is crucial when we're piloting an FPV drone, a racing car, or a remote controller boxer robot. The next question is it possible to achieve a zero latency stream with Raspberry and a Pi camera? The answer is yes. We can achieve a delay of about 200 milliseconds, and it could fit many needs. This video is not about how each particular protocol works and why these delays exist. This video is about what options we have and how to implement them with minimum friction. Even a person without deep knowledge of programming can use it and implement it. Ready? Let's go. There is not too much to say about hardware. It's as simple as possible. A Raspberry Pi 5, a camera cable, and a camera module 3, wide edition. As an operating system, I have the latest official port of Debian Bookworm. I have zero custom setup. Everything can be found in the official Raspberry Pi stores and Raspberry Pi Imager. Let's go to the official Raspberry camera documentation and try some network stream recommendations. The left menu has a RPCam with item. Press it and the page will be scrolled down to the necessary information. We can scroll down a bit more to the network streaming and let's try the UDP stream. Now it's time to connect to Raspberry Pi in a terminal window. I will have two terminals. One will be connected to the Raspberry Pi via SSH. Another one will run commands on a local machine. SSH, my user is NerdysInks at 192.168.178. Okay, we are in. I will use the text editor for convenience. Copy UDP stream command. Now we need to find a target computer for UDP stream. On my laptop, I will run ifconfig grep 192 to find my local network IP address. It ends up with 66. Copy and paste it and replace the port to any number like 5555. And we can run this command. As we can see, the Raspberry Pi sends some frames to the laptop. Now let's copy ffplate command and replace port and IP address with a Raspberry Pi IP. It takes more than 10 seconds to show even the first frame. I will speed up the process. Yes, I forgot one important detail. I need to set stream width, height and frame rate to be able to test the same video stream with the same parameters. I am adding 1280 as the width and 720 as the height, and 30 will be a frame rate. Okay, running the stream and running the player. Speed up again and finally we have the stream. Now it's time to see the performance. I have a camera that records the timer in real time and the stream that sends it through the local network. In a nutshell, the Raspberry Pi received video from the camera and sent it to the router via Wi-Fi. The router sent it to the laptop and finally the laptop shows it. We can see that UDP method of video delivery has 3.5 milliseconds delay. It's a huge delay. For example, a car traveling 40 miles per hour or approximately 64 kilometers per hour will cover 66 yards or 60 meters in 3.4 seconds. Here is what 66 yards looks like on a football field. It's not something that we can rely on when controlling a high-speed device like a drone. Let's move on to the next test. I'm going back to the browser and copying the TCP method of a video stream. In this case, I will need to set up only a port. I will use 5556 for it. I'm also copying video parameters to send and receive a stream with the same size and frame rate. The Raspberry Pi will make a stream to its own port, and any client can connect to it and receive a stream. As you can see, it sent some frames, and now it stopped on frame 14 and waiting for a listener to receive the stream. Next, I'm copying a command to place the stream on the laptop, adding Raspberry Pi IP address and port. It takes approximately 10 seconds to show the video in the window. Let's zoom out and review the latency. This TCP method of video streaming has only half a second delay, which is much better than UDP. Let's apply this delay to a car traveling at 40 miles per hour. A car would travel only 10 yards or 9 meters with this time. Next, I will test the RTSP stream. Back to browser, copy command and... Yes, it doesn't work. I have to tune it, but I hate when it's added to official documentation, but you have to complete a scavenger hunt to make it work. So for now, I will skip this part. We will test another RTSP stream later. We still have several options in this documentation, like libav integration into RPCam vid. It's a different video codec and it could affect delays. It has the same TCP UDP options, so let's try both of them. Let's copy the TCP and start it on the Raspberry Pi. Then let's use a player command with a proper port for the laptop. Surprisingly, libav has a huge delay, approximately 10.5 seconds. With the default codec and TCP we had half a second, but now it's 10.5. If we apply it to the car, we will see that a car will be far outside the field with that delay. 200 yards or 190 meters, it's not a joke. Going next, let's test the last option from the official list. Back to the browser, copy the UDP command, replace the IP address and port and run it. I'm running the player again, and I forgot about video size and frame rate. Back to the editor, copy paste and rerun. And now we have only half a second delay for UDP. Let's add all the info to the football field. These results are pretty strange. In the case of the native codec, we had a huge delay in UDP and a small delay in TCP. With libav we have the opposite. But we still can do better than a half a second. Finally, we are getting closer to our Raspberry Pi winner of the latency, MediaMTX. This software can send a stream through all the protocol mentioned previously in the video and a few more. Let's start with the setup. To install it, I need to do really simple steps. First, open the release page on the GitHub. Second, copy a link to an ARM64 archive. It's essential to choose a proper version here. Third, create a folder for it on the Raspberry Pi. Fourth, download it using wget command. Fifth, unarchive it to the same folder. Sixth, open the YAML configuration file for editing. Seventh, scroll down and paste these configurations. In a nutshell, the MediaMTX software will run this command in a bash. Next it asks rpcam vid command, the same as we dealt with before, to send a stream to the ffmpeg. And ffmpeg will send it to the media via RTSP protocol but locally. You don't have to understand what it does. We can just save the configuration and run MediaMTX. The very first prints of it have helpful information about protocol and ports that we can use. Let's try it with a VLC player and RTSP stream. We can run a VLC command on the laptop and in a moment it will show a stream. And we have a 1 and 3 second delay with this type of stream. I will show you how bad it is with a hand gesture. We saw it and it was streamed with a huge delay. Let's add this number to the football field. Finally, we are closer to our winner. Let's go back to the console and grab a port for WebRTC. In my case, it's 8889. Then just open the stream in the browser. We can type in HTTP IP address of the Raspberry Pi, :/com1. Then press enter. In a moment we have a stream. Zoom out and let's review the delay. It has an awesome 0.2 delay, which is a winner across all tests. The test with the hand is also pretty nice. At the beginning of this video you saw the example of a video stream with this latency.
Get set for the next run.
So the riders have their challenges here. It's a very technical course, very big jumps.
The cannon, the step up.
This is Red Bull Hardline, the toughest downhill race on the planet. Oh, big throw! Oh, logos down!
On a football field for the same car with the same speed, it will be approximately 3.9 yards or 3.5 meters, which is the most minor delay from all of tested before. And here all the results are in one table. In conclusions, if you are going to use stream with an FPV drone, you will need a latency 10 times lower than 200 milliseconds. You should have approximately 20 to 30 milliseconds. As for my needs, the 200 milliseconds delay is insignificant and I can implement my plans with MediaMTX. If you are looking for a delay even lower, you can try to tune the WebRTC stream and reduce the frame rate. I hope this video will help you to build your exciting project with a low latency live stream. Let me know what you think about it in the comments below. Thanks for watching.